Hello everybody. In this video we are going to be looking at problem number 5 from the 2017 Berkeley Math Tournament, uh, the geometry round. So we have a polynomial whose roots are the side lengths of a triangle ABC, and we wish to compute the end radius times the circumradius. And at first this doesn't seem like a whole lot of information, and it may seem like we have to do some factoring in order to find out what the side lengths are, build the triangle, blah blah blah. But in fact, there's a much nicer way to go about this problem, because I don't even know if this factors or not. And it involves, well, first of all, if you know a certain formula, you can get this pretty much immediately, but I'm going to prove all of the formulas so it doesn't seem like I'm just pulling things out of nowhere. So first, if we have a triangle, and we draw all of its angle bisectors, then what we get is that all the angle bisectors will cross at one specific point called the end center. And the main property of the end center is that it's the center of a circle that is tangent to three sides. So specifically, if we draw perpendiculars from our end center I, if we draw perpendiculars to I to each of the sides, we get three congruent lengths. And that tells us that, and I will denote this by r, little r, which is and this is the end radius of the circle. And so we see that since all of these are perpendicular, we can compute the areas of ABI, AIC, and so on, right? So I'm going to let this side be C, little c, this is little b, and this is little a. And so obviously each of these triangles is just 1/2 base times height. In other words, 1/2 r times a, and 1/2 r times b, and 1/2 r times c. And so if we add all of those up, we get that the area of the triangle, which I guess I shouldn't denote by capital A, but I'll denote by capital K, the area is just 1/2 times the sum of A, B, and C, which I'll just write as the sum of A, just to denote that it's just the sum of the single variables. So this is one formula for the area of a triangle. Now obviously this isn't the only formula for the area of a triangle. And obviously, so we knew that 1/2 base times height is the traditional formula, right? So what if we know that the base here is just little a, but what if we want to find this height? How can we express this height? Well, using trigonometry, we see that in this right triangle, so I've dropped an altitude from A, and we have this right triangle, and so we have this angle, which I'll just call C, angle C, capital C, and we see that the height is just b times sine C, right? That's just the definition. And so the area K for the same triangle is just 1/2 b, 1/2 AB sine C. So that's all good. But we have this trig here, right? We don't really want to deal with trig, because what they've given us is a lot of information about the roots, right? Specifically, we know the sum of the lengths, so we know our perimeter, and we know the product of the lengths. And it almost looks like we have the product here, right? We have A times B. What if we could get A times B times C somehow? And there comes the law of sines. The law of sines states that if you take any length of the triangle and divide it by the sine of the angle opposite, so in our case, if I take little c and divide it by sine of c, then this will give us twice the circumradius of the triangle. And I actually won't prove this one because this is just a well-known fact, but what we can do is plug sine of c in here. We can solve sine of c is c over 2r. So here we get ABC over 2r. And here we get our product of A, B, and C, which we know from this polynomial using Vieta's relations is just 540. And if you don't know what Vieta's relations are, just imagine you write this in factored form and then expand it and equate the coefficients. You'll see that A plus B plus C is 27 and A times B times C is 540. So now we know that, so 1/2 r, and we have the sum of the variables is a, or is 27, sorry. And this is, so that's the area of the triangle, but that's also equal to ABC, which we've said is 540, over 4r. And so now we can just solve for little r times big R. And we will get 540 over 2 times 27, which is just 10. And that is the answer to the problem. So anyway, thank you for watching this video, and I hope to see you in my other ones.